Hey guys, this is Mr. H. Today we're going to be working on generating equivalent numerical expressions using order of operations. Before we get started, make sure that you have this page printed out. If you don't, that's totally fine. What you do need is a piece of paper and something to write with. Okay guys, now you can tell that I set up my notes exactly how this one is set up. The reason why I'm doing that is so that you can follow along and take notes. So I'm going to break down each section of the notes page here. Alright, let's get started. So the first part is simplifying expressions. We do that using the strategy PEMDAS. Okay? Again, this section right here is what I'm doing here. Okay, we're simplifying an expression. The expression they give us is 78 minus parentheses 8 plus 6 parentheses divided by 2 times 3 to the power of 2. Now, if we're using this strategy, the first thing we should do to simplify this expression is do the parentheses. That's what we're going to do first. 8 plus 6 is 14. And then what you want to do is just rewrite the whole thing. The next expression. So that is 78 minus 14 divided by 2 times 3 to the power of 2. We did the parentheses. Now we got to do the exponents. All right. 3 to the power of 2 is 3 times 3, which is 9. And then we rewrite the new expression, 78 minus 14 divided by 2 times 9. Now we're at the multiplying and dividing part here. You might think it's multiplying first just because the m comes first here, but that's not the case. What you want to do is, once you get to multiplying and division, you have to check to see which one comes first in the expression. And if you notice, division comes first in the expression, so that's what we have to do first. So 14 divided by 2 is 7. Rewrite the new expression, 78 minus 7 times 9. Next operation to do is multiplication. 7 times 9 is 63. Rewrite the new expression, 78 minus 63. 8 minus 3 is 5. 7 minus 6 is 1. So we simplified this expression into several expressions, but the last expression, which is the answer, is 15. That's how you simplify an expression using PEMDAS order of operations. Alright, so remember, I'm using this page to do the notes. Okay, so I'm going to this section now, the prime factorization of a number. Okay, we're going to do prime factorization now. And the number they give us is 45. Now, in order to do prime factorization, you have to know two things. You have to know what a prime number is, and you have to know what a composite number is. Okay, and I will be giving you examples of prime numbers and composite numbers. A prime number has two factors, one and itself. A composite number has more than two factors. So I'll give you an example. So I'm going to go over prime factorization of 45, and the strategy I'm going to use for that is a factor tree. Okay, and it literally looks like a tree. So I'm thinking of two factors that I can multiply together to give me 45. Again, I'm using this paper, and the factors they give us are 5 and 9. Right? Now, I have my students circle 5. Why 5? Because it's a prime number. The only factors for 5 are 1 and 5. 1 times 5 is the only two factors that it has. 9 is composite. I'm not going to circle 9 because I can break that down. I can keep my factor tree going. 9 is a composite number because it has 1 times 9 or 3 times 3. Notice that that's more than two factors. So 3 times 3 makes 9. My factor tree is finished. Okay, I just did the prime factorization of 45. Now you have to write it as an expression, 3 times 3 times 5, or if we want to simplify that expression like they show you here on this page, okay, it's using exponents, 3 to the power of 2 times 5. And that's how you do the prime factorization of 45. The strategy is a factor tree. Okay guys, so I went over how to simplify an expression, and I went over how to find the prime factorization of a number using a factor tree. Okay, now I want you to try this problem. See, this is the part of the notes that I'm doing. Try it. I want you to do this problem on your own. So go ahead and pause the video right now. Use the strategy PEMDAS to solve this expression, to simplify this expression, and then unpause it when you're ready. Okay? I'm going to start solving this problem. Here we go. First thing you need to do is parentheses. 2 plus 3 is 5, and then rewrite the whole expression over again with the new number that you just got. Okay, the next thing, exponents, right? Because we just did parentheses, now we have to go to exponents. Right here, 8 times 8, because that's 8 to the power of 2. 100 plus 64 minus 5 times 10 divided by 2. What's the next thing you should do? We did parentheses, exponents. Now we have to do multiplication or division. Which one comes first in the expression? Multiplication. So that's what we're going to do first. 5 times 10 is 50. Now, as you're watching me solve this problem, make sure that you solved it correctly by making sure that you broke down or simplified the expression just like I did. If your expressions don't match mine, that means you did something wrong. Okay, the next step we should do is division. 50 divided by 2 is 25. And let's rewrite the new expression. 100 plus 64 minus 25. Now we're at the addition and subtraction part of PEMDAS. Addition comes first in the expression, so that's what we'll do first. And then the last part is subtraction. Gotta borrow from the 6. Turns to a 14. 9. This is a 5. 5 minus 2 is 3. So 164 minus 25 is 139. Okay, let's go to the next part. Prime factorization of 84. Remember, to do prime factorization of a number, you have to know what a prime number is. Prime number only has 2 factors, one in itself. And you have to know what a composite number is, which is a number that has more than 2 factors. To do prime factorization, you have to use a factor tree. Now, go ahead and pause the video right now. And then unpause it when you're ready to check your work. But I do want you to try this one on your own. Prime factorization of 84. Now, our factor trees might look different, but at the very end, our simplified expression should not, the prime factorization of 84 as an expression using prime numbers should not look different. That will be the same. Okay, 84, 2 factors that give me 84. I'm going to say 2 and 42 because 2 times 42 gives you 84. 2 is a prime number. I'm going to circle that one. 42 is not prime. It's composite, so I have to keep the factor tree going. 2 numbers that you can multiply together to get 42. 6 and 7. I'm going to circle 7 because that one is a prime number. 6 is not. 2 numbers that you can multiply together. 2 factors for 6 are 2 and 3. Now, the factor tree is finished. Let's write the expression 2 times 2 times 3 times 7. Want to simplify that further, you can use exponents. 2 to the power of 2 times 3 times 7. And that is your answer for the prime factorization of 84. Okay guys, and that's it for our notes. As you can see, this is the notes that came from this page, the concept development page. Now what I want you to do is do the problems on the concept practice page. Go ahead and do problems 1, 2, 3, 4, 5, and 6. This page you can find in your teacher's Google Classroom. See you tomorrow.